Hello guys. In the last video, we spoke about insertion of an element in a heap data structure, right? In this video, we'll discuss about another operation that can be performed on a heap, that is deletion. Okay. Now, like usually when you see this heap data structure, what you think, like how you delete an element. As I said earlier, a heap, it is like a pyramid. Like usually, if you go to any fruit vendor shop, they place apples or oranges like a pyramid, right? In that case, if you want to take out a fruit, how you will do? Will you go to the bottom of that pyramid and pull the fruit? No, right? You you pick the topmost apple. Whatever is present at the top, you pick that. So same here, you should not, whenever you want to delete an element in the heap, you should not delete any random element or the bottom element, because even if you see a fruit vendor shop, if you delete a random element or if you pick the bottom apple, any random apple, whole heap falls down. So what you have to do is you have to pick the topmost element. Likewise here also, whenever I say you delete an element from the heap, what you have to do is you have to remove the topmost element, which is nothing but root node. So here I want to remove, I want to perform delete operation on this. So what I have to remove the root node. Okay, when I remove 10, what you think is okay, 10 is removed. In place of 10, I should put something as a root. I'll compare 9 and 8. Okay, among 9 and 8, 9 is the greatest one. I picked 9. Okay, now here I put 9 here. Here in place of 9, what I'll do is, you don't have anything here, right? Because you pushed, like you moved 9 from here to here. Now in place of 9, what I want to do is I'll take the children, whichever is the greatest one. I'll take 6 is the greatest one. I'll take 6 here. Okay, then this thing will be removed. This 6 will be removed. Okay, when I do this, it is following the one of the properties of the heap. 9 is greater than 600, 6 is greater than 5, 8 is greater than 210. But it is not following the complete binary tree property, because a complete binary tree, at the last level you will have nodes from left to right, but as left as possible, right? Here this right child is missed. You place this 2 and 1 here, so it is violating the heap property, and the complete binary tree property of the heap is violated. So I should not do like this. So what is the standard process of deleting an element? Okay, I'll explain here. What you should do is you remove 10 here, right? So in place of 10, you go to the last level. Okay, in the last level, whatever is placed at the rightmost, here it is 1, right? You put 1 here. Okay, you just swap it. Now this is removed. Okay, when this is removed, okay, this is following the complete binary tree property, but it is not following this maximum condition, because here 1 is lesser than 9 and 8. It is not greater than. Since we are using the max heap, it should be greater than 9 and 8. So what I'll do is I'll compare 9 with 1 with 9 and 8. Okay, so among 9, 1 is lesser than 9 and 8, right? And in between 9 and 8, which is the greatest one? 9 is greatest one, right? So what you have to do is take maximum of left and right child, whichever is the maximum, swap root node with this. So what I'll do is 9 is maximum among 9 and 8. So what I'll do is I'll swap 9 and I'll put 1 here. Now I have to do the same comparison. So here 1 is lesser than 5 and 6. Okay. Now since 1 is lesser than 5 and 6, what I have to do is I have to take the maximum of 5 and 6. Maximum of 5 and 6 is 6. I have to swap that 6 and 1. Okay. Now, in case here both elements are greater than the root node, in case there can exist a condition like here 1, 5, 6, right? So let's suppose I have 4 here and I have 2 here. Okay. Now 4 is greater than 2, but 4 is lesser than 5. So I have to swap these two. Okay. Whichever is the maximum, if it is violating the maximum condition, among the left and right child, whichever is the maximum, swap it. Okay, swap both elements. Now 1 here it will go, 6 will go here, 1 will come. Now if you see, it is following the complete binary tree property, and as well as it is following this maximum condition also. 9 is greater than 6 and 8, 6 is greater than 5 and 1, and 8 is greater than 0. So we have deleted the element by following a standard procedure. Now what is the time complexity of this? How many swaps you have done? 1, 2. It means that you are doing comparisons from the root node and pushing the element to the bottom. You are doing bottom, from bottom, top to bottom you are doing it. Okay, so you can, from the root node maximum you can go to the last level, which means height of the tree. So the time complexity of the deletion is order of n. Okay, order of log n, because log n is the height of a tree. Order of log n. And this is the worst time complexity, and the best time complexity is maybe here this is the worst time complexity, and then the best time complexity can be 1 as well. So let's say all elements are equal. When I say a maximum property, it can be greater than or equal to, let's say all elements are equal, and I removed 9 here, and like when I remove the root element, even if I swap the element rightmost, last level rightmost element here, since all elements are equal, maximum you need not do any swaps. When you don't do any swaps, the like best case time complexity is order of 1. So here worst time complexity is order of log n. Log n is nothing but height of the tree, and best case time complexity is order of 1, because you are doing swaps from root node to the lowest level. So when you take insertion of an element, what you have done, you have placed element at the last level and you pushed element from last level to the top. So you are doing from bottom to top, you are pushing the element. But here for deletion, what you are doing is from bottom to, you place element at the top. From top to bottom, you are pushing the element. So operations, the directions of the operations for insertion and deletion are opposite. So this is about deletion operation in a heap. In the next video, we will talk about creation of the heap. Thank you.